Viewers, today we discuss Euler's theorems in homogeneous functions. At first we are going to the statement: if W is equal to phi of uv be a homogeneous function of degree n, then u del w del u plus v del w del v, that will be n of w, where we assume w is differentiable and have a partial derivative and have a partial derivative exist. Or have a partial derivatives. Now for the part of proof. So to prove this, we consider here at first, since w equals to phi of uv is a homogeneous function in u and v of degree n, so we express it we may express it as w equals to, here the observation, u to the power n psi of v by u. W is equal to u to the power n psi of v by u, you can say in this way. But now we observe here, in many types of differential equations for the homogeneous cases, we solve in this way, and we directly put y equals to vx or y by x equals to v. So like this, in this way we can put in this format. It is our consideration, and with the help of these considerations we can prove this theorem. Now here we are taking the partial derivative, therefore del w del u, we calculated all the form of partial derivative now and adding this and getting the result. So del w del u will be n u to the power n minus 1 psi of v by u plus u to the power n psi dash of v by u, and with the derivative, that is with respect to u, v by minus of u square. Therefore u del w del u will be n u to the power n psi of v by u minus u to the power n minus 1 into v psi dash of v by u. So in this way we are getting the value. Now again we derivative, making a partial derivative with respect to v. Therefore del w del v is equal to u to the power n psi dash with respect to v, that is v by u into 1 by v. So v del w del v, that will be u to the power n psi dash v by u sorry, here the corrections with respect to v, it will be u. So after that it will take as u to the power n minus 1 into v, and here is another terms for differentiations, that is a sorry, just to make it v into this. So we are getting del w del v, and v del w del v will be v into u to the power n minus 1 psi dash v by u. Now getting here this result and also here this result. So adding these two, u del w del u plus v del w del v, if we add u n u to the power n minus 1 psi of v by u minus u to the power n minus 1 into v psi dash of v by u plus u to the power n minus 1 into v psi dash of v by u. This total term will be cancelled. So finally we get n into u to the power n minus 1 into psi dash psi v by u. Now just a mistake here is there, just a mistake. U del w del u, that will be, it is a mistake, u n u to the power n, not n minus 1. So here is a correction, n u to the power n psi of v by u, and here this two term cancel. So we finally get n u to the power n psi of v by u. So we prove our result, that is our consideration, that is u to the power n psi of v by u will be w, so n into w. So already we have proved u del w del u plus v del w del v is equal to n into w. And there are the several other methods to prove this type of theorem. If we taking this concept as a function of xy t and is equal to some function t to the power minus n, this function of tx, another function of tx ty. So in this way you can prove by using another variable substitution, u equals to tx and v equals to ty, in this way. Now with this help of results, it's very useful result, and some problem will be solved here. This is especially homogeneous type of functions we can solve with the help of Euler's theorem. So now we solve one problem. If v is equal to cos inverse of x plus y by root x plus root y, and then verify cos v is equal to x plus y by root x plus root y is a homogeneous function of degree half. So at first, if we consider these functions, V is equal to cos inverse of these equations. So we can say it as a function of xy, if we consider it. And now here we have to verify cos v. So not taking this step, so here we find cos v equals to x plus y by root x plus root y. Now if we are considering here another function psi of xy, say, then psi of tx ty, that will be tx plus ty by root over of tx plus root over of ty. So here it will be tx plus y by root over t root x plus root y. So it will be t to the power half x plus y by root x plus root y. So t to the power half psi of xy. So it is clear from the indications that it is a homogeneous function of xy. So finally we say, hence cos v is a homogeneous function of xy of degree half. So if we change this type of equation, we can get satisfy different type of degrees of the equations. This is the homogeneous format. Okay, if we are taking here like x plus y by x to the power 1 by 3 plus y to the power 1 by 3, then the equation will reduces to like a cos v equals to x plus y by x to the power 1 by 3 plus y to the power 1 by 3, and finally that will be found t to the power 1 minus 1 by 3, that is t to the power 2 by 3. So it is a homogeneous equation of xy with degree will be 2 by 3. So in this way we can get different type of homogeneous equations for functions of the degree, different type of degree. Now the second part, another concept, there is a second part. It's the verifications of homogeneous function of degree half. Now if we have to prove second part of the question, and it is the first part. If we prove it, it is a homogeneous function. Hence if we prove x del v del x plus y del v del y plus half of cot v, that will be 0. Now for this, using Euler's theorem, x del x of cos v, that is x into some function del x of some function, and y del y of cos v is equal to degree half n of the function, and this function is cos v, n into cos v. Taking the derivative, minus x derivative of cos v with respect to v, the chain rule using sin v into del v del x minus y sin v del y is equal to half of cos v. It will be x del v del x plus y del v del y is equal to minus of cot v. Then that will be x del v del x plus y del v del y plus half of cot v equals to 0. So finally we prove this result. X del v del x plus y del v del y plus half of cot v equals to 0. So using this Euler's theorem, we find one application of the Euler's theorem. So today, now just to end of a class, it is better to verify another kinds of results of the Euler's theorem of the similar function left as an exercises. If u is a function of tan inverse x cube plus y cube by x minus y, then prove that x del u del x plus y del u del y sorry is equal to sine of twice u. This is a question that left as an exercises. For the similar manner we can solve it. It will be tan u is equal to this function is equal to phi of xy. If we solve it as a tx ty, we can get the homogeneous function of degree 2 t to the power n of phi of some function of xy. So it is also the homogeneous function of degree 2 using the Euler's theorem. X into del x of tan u plus y into del y of tan u into twice tan u. So it will get x sec square u plus y sec square u is equal to 2 tan u. So it will get x del v del x plus y del v del y is equal to 2 tan u by sec square u. That means 2 tan u tan u by sec u is equal to sin u. 1 by sec u is equal to cos u. 2 sin u cos u equals to sin twice u. So in this way we can prove this theorem. It is left as an exercises. So today we end our classes. Thank you.